So there are actually a lot of people who have opinions about what acids are,
Okay.
like, chemically speaking. One of those guys was Arrhenius.
Arrhenius.
So it's really important that we know who that guy is.
Okay.
Arrhenius was a super smart guy, and he said that an acid is anything that donates an H plus proton in a chemical reaction.
Okay.
Arrhenius acids donate H plus in a chemical reaction.
So hydrogen. Okay.
Yes.
Donate a hydrogen ion.
They donate hydrogen ion, and that means that the concentration of hydrogen ions in the solution will go up. Will increase.
Well, yeah.
They go up. They increase right there.
Okay.
Which means that bases kind of do the opposite. They actually donate OHs.
Okay. All right. Well, that would make sense.
Arrhenius bases donate OHs in a chemical reaction. So the OH concentration will go up. All right.
Okay.
So, and a really easy way to identify those, aside from like actually doing a chemical reaction, like if you saw it and it has, if you saw the name, the chemical formula, and had an H in front, that makes it an acid.
Oh, like HCl.
Exactly, right? Like the ones we got up here.
Right.
So you've been seeing those for a while now.
They begin with an H, so I know it's an acid. Okay.
So we got HCl, like you said. What's another one that we've seen before?
Oh, I'm not sure. Let's see.
How about sulfuric acid?
Yeah,
Seen that
was H2SO4, isn't it? Well, they're really easy to identify by the name.
Yeah. But if you don't have like the actual name spelled out, you can look at your chemical reaction or your chemical formula. I mean.
All right.
And then OHs will have an OH on the end. That makes it pretty simple. They'll have an like NaOH. That has an OH on the end, and BaOH2. That's another one. Right. And KOH, potassium hydroxide.
All right. So those all end in OHs. So those are
Arrhenius bases.
Okay. Great. Oh man, I sneezed so hard my clothes changed. Okay.
Oh, mine too.
Whoa. All right.
That's weird.
Yes. All right. Well, what were we talking about? Arrhenius acids?
Yes, that's how you pronounce it. Arrhenius acids.
And Arrhenius bases. Okay.
So the other definitions that we have for acids and bases are Bronsted-Lowry. He was another guy who had opinions about what makes an acid and a base a base.
Okay. All right.
And he was like Swedish or Norwegian or something like that. So a little line through the O.
Okay.
The Bronsted-Lowry definition of an acid is that it releases a hydrogen proton. It's anything that releases a hydrogen proton.
Okay.
So it releases H plus. Now it's kind of different from, I mean, it's pretty similar to donating.
Right.
This is kind of more referring to like in a chemical reaction, the one that gives away a hydrogen proton.
Okay.
Is the acid.
Okay.
But the great thing about the Bronsted-Lowry definitions, especially of a base, is that it includes ammonia.
Okay, why would it include ammonia?
Because the Bronsted-Lowry definition of a base is anything that accepts a hydrogen proton.
Oh.
So.
And ammonia doesn't have an OH anywhere in it.
It does not. So that's why the Arrhenius definition of a base didn't really cover all of them, right? It was just like, oh, this is anything that has an OH in it. Well, anything that accepts the H plus proton that the Bronsted-Lowry acid is giving away counts as a base.
Okay. All right.
So this includes NH3, ammonia.
All right.
So that's why we like that one.
If it accepts a H plus ion, it would then become NH4 and have a positive charge.
Ammonium, which is the acid.
Okay. All right.
We're not just talking about OHs in there.
Okay. All right.
So that's a whole lot of information.
It is. It is. What do I use this information for?
Well, now that we can identify it, right?
Yes.
We can do some practice problems. We can identify acids and bases.
All right, so let's take a look at some of the problems we're going to use here.
Let me zoom in just a little bit.
Yeah, please. It's a little hard to see. All right, so let's look at this first thing. Looks like we've got HCl and H2O that combine to make H3O minus 1 and Cl plus 1.
Okay. So a couple of things we might want to write down is, because I don't want to write out like acid, base, all that for these. We're going to be labeling these.
Okay.
We're going to label the acids with an A for acid, the bases with a B for base, and then some new terms that we got is conjugate acid, conjugate acid, and conjugate base. Yeah.
Okay.
So the Ca and the Cb, those always go in the product side, and then the acid and the base always goes on the reactant side.
Okay, so let's take a look and see what's going on with this reaction. We've got, it looks like the hydrogen is jumping off of the HCl and going over to the H2O.
Oh, okay, so that's a clue right there. If we remember what the Bronsted-Lowry definition of an acid is, it means it releases the hydrogen proton, and then the Bronsted-Lowry definition of a base is anything that accepts it.
Right.
So you said that it jumped off onto the water, so it means H2O accepted the hydrogen proton there.
Right. Okay,
So that makes that one the base. H2O, water is our base,
and
then the HCl would be our acid.
Right.
So that's the reactant side.
Okay.
Now for the product side, which one of these do you think is the conjugate acid and the conjugate base?
I think the conjugate base would be the Cl.
That's
plus
right.
1.
There we go. And the H3O right there, you see it's got one more hydrogen than it did on the reactant side. It accepted the the water accepted it, and became our conjugate acid right there.
Okay.
It's got one more proton than it did before.
Right.
So we can say down here, HCl is our acid.
Okay.
And then H2O is our base.
Okay.
Very good. All right, how about the next one?
Okay, well, let's see. We've got 2 carbons, 3 hydrogens, and 2 oxygens. Then we've got 2 hydrogens and 1 oxygen. It looks like a hydrogen jumped off of my H2O.
All right.
Went over to the other side.
So in this case, H2O released the hydrogen proton. So that automatically right there, that makes it acid. It makes an acid here.
Oh, H2O was a base in the last question.
Oh, that's a really good point. Okay, so let's go back to something we learned about water.
Okay.
Right? Water can go either way. There's a fancy word for that.
I remember that.
Starts with an A.
It's amphoteric,
that's right.
isn't it?
Water is amphoteric.
It means it can be an acid or a base.
Can be an acid or a base. So we'll underline that word right there, amphoteric. We want to remember that.
Okay.
So we can't just assume that because water has an H in front of it, H2O has an H in front of it, that it's always an acid, because it can be a base too.
Okay. So
this is the acid one. What's
that means the other one's going to be our base. Okay.
And it made something. It's got an H in front of it right here.
So that's going to be my conjugate acid.
That's going to be our conjugate acid. That happens to be acetic acid, I believe.
Yeah.
And then the OH right there is our conjugate
base, because it's ready to accept another proton.
There we go. So we see water over here was an acid,
and
then became a base, and then the acetate was a base and became an acid.
Okay. I think I understand.
They kind of switched jobs, right?
Right.
So the acetate right here is our base, and then H2O is our acid.
All right. Great.
Pretty simple, right?
Yeah. All right. So I want to take a look at these guided practice problems that we have.
Okay.
Oh, man. Okay. Let's see. We've got NH3 and H2O, and we've got NH4 and OH. Okay.
Let's take a look at what water is doing here.
Right. So I've got...
It goes from H2O to OH minus, right?
Okay, so it lost the hydrogen.
It lost the hydrogen. It lost the proton.
proton.
So that makes it the acid here in that case. I can't really see that very well. It's an A right there.
Okay.
And NH3 in this case because it accepted the hydrogen proton, which is
Mhm.
part of our definition of a base. That makes it our base right there.
Okay.
And then on this side, the one that becomes the acid, we call that a conjugate acid. And that would be the NH4 in this case, right here.
Okay.
And so that makes OH the what?
Conjugate base.
Conjugate base. So NH3 is the base,
Okay.
and H2O is
The acid.
Man, water just loves switching jobs, doesn't it?
Yep.
It's going either way.
Mhm. So then we've got NH4 with +1 charge.
Yep. I'm
That
gonna
means
go over there.
that's going to be my conjugate acid now,
Yep.
right?
Conjugate acid,
Okay.
and then OH
Would
is
be
our
my conjugate base.
Yep, very good.
Okay.
All right.
All right.
Last one. See what you know.
All right. So let's take a look at this. All right. I've learned that the trick to this is to look at what happens with the water. So I see my water here starts with H2O, and then it
Right
turns into H3O. So it gained a proton.
That's right. It accepted it.
It accepted a hydrogen.
So that makes
So,
it the base,
a base.
right?
Right.
And that makes the HCO3, our carbonic acid, be
Right.
what?
That's the acid.
Very good. You go mark that with an A.
Mm-hmm.
And then H3O plus,
Would be my conjugate acid,
Ca there.
and then that's my conjugate base.
Very good.
Okay.
So HCO3
Right.
is our acid. Water is our base. H3O plus is
Our
conjugate acid. Oops, can't write a J. And CO3 is the
our
conjugate base.
Okay.
All right. So remember, if you get stuck, ask your teacher for help. Right?
Okay.